In this video, we'll show you how to conduct and interpret a chi-square test of independence in R. We'll be working with RStudio, a program that makes it easier to work with R. The chi-square test of independence is a test that we use to determine whether there is a relationship between two categorical variables. For example, it can help us to assess whether students' preferred reading format is associated with their gender. The data set for a chi-square test of independence must include two categorical variables. In our example, these are gender and preferred reading format, that is, whether students prefer reading print books, ebooks, or audiobooks. We've already imported our data into R. If you're not sure how to do this, I've added a link to our video on importing Excel data files into R. Here's a screenshot of our dataset. It contains 40 fictitious students, 20 males and 20 females. Our goal is to determine whether students' preferred reading format is associated with their gender. If your data frame is formatted like ours, where each column represents a variable and each row represents one of your subjects, it's important to create a contingency table before conducting the chi-square test. Contingency tables summarize the relationship between categorical variables. The command to create a contingency table in R is on screen. You'll need to replace the highlighted text as follows. Contingency table, the name you give to your contingency table in R. You can use another name for your table if you want. X and Y, these are the names of the two categorical variables. It doesn't matter which variable is X and which is Y. DF, the data frame that contains your variables. The command for our example is on screen. The highlighted text is specific to our example. I'm just going to type this into RStudio and select the Enter key on my keyboard to execute it. If we go to the Environment tab in the top right of the screen, we can see that this contingency table has been created in R. To display the table, we just type the name into the console and then select the Enter key. Here is a screenshot of the contingency table for our example. This table shows how many males and females prefer each reading format. We have the same number of males and females in our study, so if preferred reading format did not differ based on gender, we'd expect roughly equal numbers of males and females across each format. Our table shows that males are more likely than females to prefer audiobooks and ebooks, while females are more likely to prefer print books. However, we don't know if these differences are significant. To find out, we need to conduct a chi-square test of independence. Before we run the test, though, let's look at the test assumptions. Both variables must be categorical, for example, gender and preferred reading format in our example. The groups in your categorical variables are mutually exclusive. For example, students' preferred book format can't be print books and audiobooks. Independence of observations. The expected frequency for each cell of your contingency table is at least 5. We already know that our data meets the first 3 assumptions, so we just need to create a contingency table of expected frequencies to check the 4th assumption. The command to do this in R is on screen. Just remember to replace contingency table if you gave your contingency table a different name. I'll just type this in the RStudio console and select the Enter key on my keyboard to execute the command. Here's a screenshot showing our expected frequencies contingency table. As you can see, the expected frequencies for all of the cells in our table are 5 or more. If you find that some of the cells in your table show expected frequencies of less than 5, you should conduct a different test like Fisher's exact test. I'll include a link to our tutorial on conducting Fisher's exact test in R. Okay, so now we're ready to perform the chi-square test in R. The command is on screen. Again, just remember to replace contingency table if you gave your contingency table another name. I'll just type this in the console and select the Enter key to execute the command. So let's have a look at the results of our test. The most important thing to look at here is the p-value. A p-value that is less than or equal to the alpha level we have set for the test indicates a significant relationship between the variables. It's common to select a significance level of 0.05 or 0.01. A p-value that is greater than the alpha level we have set indicates that there isn't a significant relationship between our variables. For our example, the p-value is 0.03063. Since this is less than our alpha level of 0.05, the test is significant. So based on our fictitious data, there does appear to be a relationship between students' gender and their reading format preference. It's important to remember that a significant chi-square test does not prove that there is a causal relationship between two variables. It only indicates that there is a relationship or association between them. Well, that's it. If you'd like written instructions for this test, please head over to our webpage at easyspss.com. And if you'd like to see more videos like this, please subscribe to our channel.